Let's see, we are live. Let me widen the screen here. Let's see. Hopefully you should all be able to hear and see us clearly. If not, please let us know. So hi everyone, welcome to this live e-drilling webinar presentation. Thank you very much for tuning in and joining us today. I can start by introducing myself. My name is Alina Sundaskreif, and I'll be taking you through the next 30 minutes of this webinar presentation on avoiding sidetracks and hazardous incidents with automated monitoring. And as you can see, I'm joined by two of my colleagues who I will introduce to you very shortly. But before we do get started, let me just lead you through some general information about this webinar. So if you are new to these webinars, or if you are new to e-drilling in general, we are a software company that bring our unique technologies to the drilling world. And if you are familiar with us, very nice for you to join again. We are planning to continue to use this webinar platform, so you might have noticed that it's a bit different this time. So if you do have any feedback on technical matters or the registration process, please let us know, as we fully rely on your feedback to make sure that these webinars run smoothly moving forward. So let me introduce you to Christian and Morten. So Christian, he will be taking the lead on the presentation today. He is our VP in product strategy and management, and his background is in project management, drilling and wells, as well as software. And it is also actually Christian's first ongoing year in e-drilling, so we are very much happy to have him present on behalf of the company. Morten, our CTO, is also tuning in today during our Q&A session. So his background is in AI, predictive analytics, and digital twin technologies in well construction, from optimizing drilling plans to real-time optimization. So just a very short introduction about the agenda before we get started. Christian will take you through the updated e-drilling client study and the reports from 2020, and also give you a software overview of what software was used to achieve these results. And he's also going to take us through a couple of client examples to exemplify these cases as well. And this is a fairly short webinar on 30 minutes. However, we have dedicated some time, approximately 5 minutes, to answer your questions during a Q&A session. So to your right, you might have noticed there is a chat. Feel free to use that, but I do recommend that you send me private messages for any questions that you would have, and you can do so by clicking on the icon as you see I mentioned in the chat. So I think that is enough information about the introduction of the webinar. So without further ado, Christian, the word is yours.
Thank you, Alina. So the background for having this webinar is that each and every year we have a study of how our clients are doing using our software. So there are many things that we measure on, but most importantly, we measure on number of sidetracks, hazardous incidents, and as well as significant performance improvement. So we are happy to see that also the past year, we have a 100% track record when it comes to no non-geological sidetracks and no hazardous incidents, as well as we've seen quite a boost in performance improvement. So as Alina said, in the agenda for today is that I will talk a bit about the software technology, the software applications that we have, and lastly, see how our clients did it specifically. So we have quite an international footprint. Our software is being used all around the world, as you can see in the Americas, in Europe, in Africa, and in Asia. So it has been used on a wide variety of different wells and different environments, and that just gives more feet to the feature here. Our software is built on digital twin technologies, meaning that we use the anatomy of the well, the real-time measurement, both from subsurface and topside. Then we have advanced mathematical models that create a digital twin of the well. And there we can see the difference between what is being measured and what is being calculated, so to detect any anomalies. And to do this, we have artificial intelligence and machine learning algorithms that all the time navigate between the physical world, the digital world, and then see if anything is happening. So by having this, we can do diagnostics, predictive analytics, forecasting, and what-if analysis. And by having this digital twin, it can be used across the whole well life cycle. So from planning the well, doing the well construction, the design, drilling operational procedure optimization, going into preparing for the well, doing trial runs, checking the procedure and equipment, do training, and go from the regular drill well on paper to have a drill well in simulator. And when it comes to the operations, you can do real-time optimization, look at diagnostics of the well, and have decision support. And then lastly, when you're done drilling your well, you can analyze it, see how it went, track your lessons learned or have lessons learned sessions to see how it went, as well as have competency transfer. So now let's see a selection of our software and how this has contributed to having no sidetracks and no hazardous events. In the planning stage, we have the well planner application for drilling plan optimization. And this is based on using the dynamic simulations that we have to do calculations and simulations to improve safety margins and then reduce well planning time as well. And this can be done in two different ways. Either a lot of our clients, they buy a license from us and use the applications that we have straight away. But lately, we've also seen that a lot of E&P companies, they have their own platform and ecosystem. So they are then gathering a lot of different software from different vendors into their own platform and just want to call on an API to do the calculations and run the simulations. And that is the reason why we have developed an open API and have Well Planner as a microservice. So this is now being rolled out for a few clients, and it's quite a modern way of doing things. When it comes to preparing for the well, we have WellSim, which enables you to do a drill well in simulator instead of a drill well on paper. And here you can take the existing data for your upcoming well and to create a simulator environment. That means that when you are preparing for your well in this simulator, you can see how your well is going to respond. And that means that your drilling engineers, also if you want to include some rig contractors and drilling personnel, everyone can gather in and then do preparations in it. So run the procedures and see how the well behaves. And then enables our client also to run or look at different high-risk scenarios. So when they go to the rig on site and do the actual drilling, they will be prepared, and if something happens, they might have seen that before in the simulator. So when it comes to the operation itself, we have Well Ahead for automated monitoring and real-time optimization, as well as live well support. So Well Ahead can be used in different ways. It has been used on the rig, where we have 3D visualizations in the drilling cabin. So there, the driller can have a 3D view of what is actually going on in the well. So we can follow the BHA when going in and out of the well. We can see then the formations. There can be info messages in it, so to be aware of any risks that are upcoming. It can be used in real-time decision support centers and also in teams supporting drilling operations. And Well Ahead will then run diagnostics between the real-time measurements and the calculated models, so that it can give warnings when something is happening. So as you see on the figure on the right side, these can be potential influx, loss, impending stuck pipe, and so on. And in many occasions, we have seen that these diagnostic messages are being sent to engineers and crew many hours before they actually detect the issue themselves. And that means that they have quite some time to react and do the appropriate changes to avoid these situations. And sometimes when we've seen that a diagnostic message has appeared and is being ignored, we can see then the crew and the engineers going into these problems several hours later. So the moral of the story here is to listen to the software and the artificial intelligence. And it is also the foundation of any viable rig site automation. So let's go over to some more specific client examples. Here we can see one European E&P company that had a challenge with sidetracks. And they were seeing that the wells they were drilling had 25 to 30% non-planned sidetracks. So the solution was to deploy eDrilling's digital twin. And this has been done since 2017 in over 60 wells. And the results we were seeing was that there were no sidetracks. The drilling parameters improved during operation. The operations were prepared for often in a simulated environment in drill well in simulator, so that everyone was aware of the risks in the well and prepared for that upfront. And it decreased the carbon emission through NPT reduction. So it doesn't only save time and cost, but avoiding NPT, avoiding sidetracks, less time on the rig, it also decreases the carbon emission. And that is already important now, but will be more so in the future as well. Another example is from an Eurasian E&P company, where the challenge they saw was the need to improve drilling efficiency. So 75% of the employees' resources were used on data acquisition and tasks that were manual and didn't contribute much to the overall results. So the solution here was to utilize the software, leveraging AI, and then especially to aid in decision making. This enabled the software to do routine tasks and monitoring, and also increase the cross-team collaboration. So the results they reported were an NPT rate reduced by 8 to 10%, drilling rate improved by 20%, and they had 300% more wells supported with the same headcount. When you have a system for doing automated monitoring and giving you info messages when something is occurring, and also perhaps how you should act, it says itself that it is possible then to address a larger number of wells per head count, because then you will get notified when something is happening in the different wells that you are monitoring. And this also increased the focus on safety within the team. Next example is from an Asian E&P company, and their challenge was that they needed to strengthen the well construction process. Also, they were seeing that a lot of the data generated from planning and drilling the wells were unutilized. I think we can all relate to the vast amount of data that is actually being generated, both in the planning and during operations in drilling and wells, and a lot of it is saved, but then never used. So their solution was to create an advanced drilling simulation and engineering center, and then bring on board eDrilling software and use it through the well life cycle. So then in planning, in preparation, operations, and post-analysis. And the results they reported after we were doing this was that they saw 30 to 40% fewer complex situations and accidents. Drilling efficiency improved by 20%. and they had $80 million saved over 100 wells since 2015. And having all this together also increased their focus on safety. So now we've covered some of the client examples that have been accumulating over many years. So I thought I'd include one of the very recent wells we did as well. And the challenge they were seeing was they were operating in a heavily operated field where many wells have been drilled before. And the main risks included losses, insufficient hole cleaning, hole instability, and stuck pipe incidents, to mention some of them. So the solution was to implement Wellhead for automated monitoring and also do forecasting simulations during operations to then maximize the value given and see where the safety limits were. And the results reported from these operations was a vast amount of automated diagnostics. So a lot of messages were being sent out that something was occurring in the well, there was an anomaly, and they were able to then to take the measures needed to get back on track. Otherwise, the tripping went 42.5% faster. They increased the drilling efficiency by 46.5%. And tripping through tight spots were done looking at the real-time 3D visualizations in the drilling cabin. So they could follow the BHA going through and then keep sure that when they came to tight spots that they were monitoring closely. So in summary, the study has been done by going out to our clients, which are operating all around the world. Cumulative, we've now had 6,000 users on the e-drilling software applications. We made more than 200 digital twins. And all of this has shown that automated monitoring gives an increased performance, reduces carbon emissions, and we have had no non-geological sidetracks and no hazardous incidents while this has been implemented. So we are very happy with those results, and we know that our clients are also very happy about that. And that was all for the webinar itself, but I'm sure that some of you had used the opportunity to ask questions. So let us go over to the Q&A session.
Thank you, Christian, for your insightful presentation. So for now, I don't see any messages or questions in the public chat. However, I have received a couple in the private chat, so I'll start with those. Again, do feel free to use the public chat if you have any questions during this Q&A session as well. So Morten is tuning in now. Morten, I have a couple of questions for you. One attendee is asking specifically about WellSim, and the question is, what drilling-related hazards can be modeled through WellSim?
Yeah, that's a good question. So first we need to kind of understand that the WellSim modeling that is done in WellSim is dynamic modeling. That means that how the well behaves is kind of a dynamic thing, that so everything you do to the well, it will react to it. And to achieve that, there is also a dynamic reservoir model inside the model. That means that if there is a reservoir and you get underbalance or whatever, the well will produce according to the various dynamic parameters. In addition to that, there is also a possibility to have weak zones, so you can frack the well and do ballooning or wellbore breeding. But on top of that, there is also other problems that can be modeled to achieve a realistic kind of preparing of the operations, and that goes to stuck pipe. So you can have both mechanical stuck and diff stuck situations, other things like blocked nozzles or washed out drill string. So there's a various amount of events that can kind of be done in the simulator. But I think it's also important to understand kind of the complexity of the simulator in the way that you basically drill the well you are going to drill. So everything you know about the well is configured into the simulator. That means the fluid properties, the formation properties, temperature gradients, and pore and frac pressures, and so on, that allows you to have the exact same well that you are going to drill. And based on when you have that, and you have a toolbox of different events that can occur, you are able to model all different scenarios. And also, of course, we have to need to remember that like operations like managed pressure drilling or dual gradient drilling is also supported. So it's a very generic simulator, but it has a lot of features to be used to achieve what we need this type of simulator to achieve. And you cannot compare it to other kind of drilling simulators. So it's not a pure training simulator. It's a lot more complex and advanced than that.
Okay, thank you very much, Morten, for clarifying. I have another question on scalability, which is quite relevant in this webinar as well. So one attendee is asking, is it scalable? For example, is the software for just one certain number of wells at a time, or can it be scaled up and down according to our needs?
Yeah, so that was a quite general question, but if you look at all the different kind of applications or software packages we have, like the well sim training or preparing for operation, that is kind of one thing. You work on one well at a time. Of course, you can configure it to do all your wells you want, but one at a time. But both the real-time automated monitoring system and also the well planning microservices is preferable run in the cloud in a Dockerized system that allows for scalability. That means that both the hardware resources that it needs is kind of scaled when needed, and at the same time, as a customer, you can, for example, if you have one day you have 3 wells, and next day you have 10 wells, then they easily scale up, but also scale down again. So this is a good way to kind of reduce the cost of everything. Yeah.
Okay, thank you. I still have a couple of questions left here in the private chat. One is regarding microservices, and I think this is an important one to address. We actually had a webinar regarding this matter about 1.5 months ago. So if you are interested in microservices as well, you can watch that one. But the question is, you mentioned the microservice. How is this different from the planning software you already provide? From the planning software you already provide, sorry.
Yeah, so we started making our well planner application to do dynamic hydraulic and temperature simulation, torque and drag simulations, and also well control and kick tolerance. The well planner microservice is, as for now, that is a microservice for the dynamic hydraulic and temperature simulations and torque and drag simulations. The other modules will come later on. But the difference between the two approaches is that the microservice is not an application with a user interface. It's a service that is run in the cloud, where you as a customer with the infrastructure you can trigger simulations in the microservice. So the system will then make the calculations for you, and it will provide you with the results, and you can then do all this in your own infrastructure. And there's more and more common that customers have their own infrastructure for this. Yeah.
Great, thank you. Also, we can discuss a little bit around the deployment of the software, as that is one question that did come in right now. One is asking, how is the deployment of the software? Are you providing an engineering service or just selling the software?
Yeah, good question. We have a very open way of working with our customers. So we try to fit what needs the customers have. That means that we might be at some customers, they just have our software. They might just have it installed in their data center. It might be our software running in our cloud that is provided for them. But it might also be on the other side of the scale, where we have our engineers in the operational team doing the engineering work using our software. And also, we also have customers doing something in the middle there, but where the customer is doing all the kind of the engineering work, but we are providing a service where we make sure the system is working as it should with the correct data from them and so on. Yeah.
Okay.
I think that answers it.
Okay. I have another question here that's related to what you just discussed or spoke around, Morten. Is it difficult to get started is the question. For example, do you provide courses to train or personnel?
Yes, of course. The level of mathematical model we do is quite complex. That means that there is a certain level of information or knowledge the users needs to have. So therefore, we provide training for our customers. That could be an online course. It could also be a course that we do at the customer's office. And also what we do is, or very often is also what we call on-the-job training, where we have our service engineers working together with the customer, maybe on a well or two wells, to make sure they really learn how to use it. And very often we do a combination of all those three ways of doing it. Yeah.
Okay. I think you already answered this question, but maybe we can clarify that before we wrap up this webinar. One attendee is asking, can the software be run in the cloud?
Yeah, so that has been a big focus for us for quite some time, is to be able to run everything in a cloud to make it easier accessible for all the users that is needed to have it. When we started doing e-drilling, we run everything in the customer data centers, and that there's some benefits of that, but having it in the cloud makes it much easier for scalability and accessibility. But we actually can do both still. Okay.
Fantastic. Thank you, Morten. So I have no other questions in the private chat. Looks like we are out of questions in the public as well. If any attendees left want to ask anything, the chat is still open, but for now it seems okay. So we are out of time as well. So I think we can wrap up this webinar. So thank you everyone for attending. Thank you for tuning in. As mentioned, we will continue to have monthly webinars. So hopefully we will see you in May as well. Again, please do reach out to us if you had any issues with the registration or technical matters. You will also receive a recording of this webinar a couple of hours after this session ends. So thank you, Christian and Morten, for joining us, and may all of you have a good day. Thank you very much.
Thank you.
Thank you. Bye-bye.
Bye, everyone.